G'day there, guys, and welcome back to the Aussie Engineer. Today, we've got a interesting tutorial for you. We're going to diving into the world of VLANs, showing you how to set them up on EdgeOS. Whether you're a seasoned pro or just getting started, stick around because we've got you covered. But first, let's break down what VLANs actually are. So, all right, let's start with the basics. VLAN stands for Virtual Local Area Network. Think of it as a way to logically divide a physical network into multiple isolated networks. It's like having multiple separate networks coexist on the same physical infrastructure. They are great for security, traffic management, and segmentation. So the best way to think about it and why I use a VLAN is if you have smart devices or IoT devices on your network. And the reason for this is these devices at times can be questionable with their origin and what or where they communicate with. They don't have the greatest security reputation at all. So personally, I don't allow my smart devices to communicate with the internet or their cloud-based servers. So how I stop them from doing this in particular is I segregate them onto a VLAN of their own. And from there, that also isolates them from my other devices, which provides additional security to me. So each VLAN is like a tag, and they indeed have their own VLAN IDs. These tags are like, and the easiest way to think about it is like different jerseys on soccer football players. When you look at the color that a player is wearing, you know which team they're on. And from this, you know what to do, what to think about them. I.e. which way they're going. The same thing works with VLAN tags. These tags allow networking devices to know how to handle the traffic, and if set up correctly, different VLANs can't communicate directly to each other unless, obviously, you set up special rules for it. One bit to note is the default tag that is applied to traffic on your networks will be 1, which is the default VLAN if you don't have any VLAN set, and then you can set them from there. So if you look at the example on the left, we have two separate VLANs or virtual LANs running off the same interface. And this could be determined by the port. This could be determined by, for example, which Wi-Fi SS IDs they're connected to. We have VLAN 1, which has IP addresses in the 192.168.1.0-24. subnet, and then the other ones are 192.168.2.0-24 subnets. And that the traffic from them, depending on how you set it up, will be separate, and you can block off, for example, the VLAN 20 from the internet to provide additional security, or you could stop devices talking to each other between the different VLANs as well. So now that we've got the basics covered, and later on, I'll talk about why I find the soccer player analogy useful, because especially the first time you set these up, depending on the amount of network equipment you have, you can and often will run into different issues along the way, and we'll talk about why this is relevant. All right, so moving on, I've already logged onto my router, and you'll see I've already got a virtual LAN set up on my LAN network, and that is VLAN 20 on the Ethernet port 7. So what we're going to do is I'm going to add an additional VLAN onto the network, and I'm going to add that on to the same interface, so port 7, and we're going to call it VLAN with a tag of 30. So the first step is you want to add that interface. In this case, obviously, it's a VLAN. Let's call this one. So the ID firstly is 30 that we want to use. I want to put it on port 7. And the description I want to use is going to be, I don't know, let's say IoT. So I'm going to put all my Internet of Things stuff onto this, all my smart devices. The last bit you need to put on here before you close it out is to manually define an IP address. And the IP address I'm going to use for this one is 192.168.3.1 with subnet of 24. So this .3.1 will be the address of the router inside that net, and it will also help when we come to the next step, which is setting up our services on this. So we go ahead and save. We'll now note that we have an additional VLAN that has been set up, and at the moment we're good to go and we should be relatively happy. So the next bit we want to do is we want to come across to the services tab, and we want to set up a DHCP server onto this specific VLAN. So we just add another server. Let's call this one, what do we want to call this one? Let's call this one IoT DHCP. The subnet we want to use for this one, 192.168.3.0-24, which matches once again. So this subnet will match the IP that we set for the actual device. We want to set the start range of this from .2, the range stop to, let's go 200. I don't need all of the addresses. The router address is the same as the first bit that we set up, and the DNS is the same for that as well. And then we hit save. So what the device will now go ahead and do is it will now set our IoT DHCP server. And I like to come in and just confirm and check that the status is enabled and everything matches and I haven't entered anything in here incorrectly. All right, so the next bit that I like to do at this stage, now that we've set this one up, is to add the port forwarding bits. So I come across to our, all right, so the next thing I like to set up now is our port forwarding. And what we want to do here, noting that you should already have port forwarding elements set up, is that we want to add a LAN to it. In this case, we come down and we should see our ETH7, so port 7.30, which will be the VLAN that we've got. And we just apply that now. Okay, so far we're good to go. And basically any packet which comes into the router which is tagged with the VLAN tag of 30 will now obviously pick up an IP address from that 192.168.3.0-24 range, and will obviously then be on that VLAN. All right, guys, so one of the bits we've got to do now is we've got to ensure that the DNS under the services is set up to include the listening interface for the VLAN that we've just set up. So what we do is we come across the services, then to DNS, and then we just add the listening interface, which in this instance is going to be the ETH 7.30. And once we've got that, we just now save that in. So the next bit that we want to do now is actually have a look at how we set some of that. So how do we actually go about getting those flags on? So how do we get the jerseys on? So the best way that I do that is because of the Wi-Fi access points, and I have a Ubiquiti network and Wi-Fi devices, I can set it through there. So I can flag traffic specifically through the different SSID that things sign up onto. And in fact, my guest VLAN, which is the Aussie Engineer, if we come across and have a look at the settings inside here, we'll note that it is on the guest VLAN network. All right, so let's actually come across and have a look what that means. So inside the networks, you obviously have the default one, which will be set up here. But then in this instance, we want to now create a new one. So IoT devices that connect through one of our SSIDs, we want to flag as belonging to that VLAN. So what we do is we come inside here, we give it a name. I'm going to say IoT VLAN, and then I want to set that flag so that tag, if you will, or jersey to 30. We just now add that network. Happy with that. Come back up to our Wi-Fi networks, and I'm going to add it in this instance to the Firkin and Firkin 5 Wi-Fi networks. So we come along, we change the network to IoT VLAN, apply changes, we come to Firkin 5, and then we do the same on that one. So now that what that means is, quite simply, any device which connects to the SSID's IoT VLAN, any device that connects to the SSID's Firkin or Firkin 5 will be assigned to the network IoT VLAN, and their packets will be amended with that 30 flag. So the 30 jersey or red jersey, green jersey, whatever you want to visualize that as. That will then mean that that traffic will then come across and will be picked up by the router over here. So what I'm going to do now, just to show that this is working, I am going to, if we look down the bottom on here, I'm going to connect to that SSID on my phone. So we connect to Firkin. All right, guys. Now we've got our VLAN set up. Let's come across and test it. So what I'm going to do now is I'm going to log on to the Firkin SSID, and what we should see, and what you can already see down the bottom, is there's clearly traffic on this, indicating to me happy times, that it looks like we are communicating. The next bit we do, and for me, the final check that I do, is I come across onto the services, and then I have a look, and what we should see is that one of our, in this case more, so I have other devices which are clearly connected already to this new VLAN, have leased IP addresses from the DHCP server, and this to me says everything's good. And in fact, if I go back to my dashboard, go to the internet on my phone, I can see that the internet works, and more importantly, from what you guys can see from the router, you will see now that the traffic spikes when I start doing this, and when I start running the tests along to that VLAN. So that says to me everything is good to go, everything is working. Now there is one additional bit that I kind of want to show you guys before we move on, and this is one of those pitfalls, which once again the jersey analogy really helps with in this instance. So when I first set this up on my computer, I was getting traffic, no traffic initially, absolutely no traffic was coming across, even though everything was set up exactly as you've seen now. What was happening is the switch in the middle was removing the flags, and this is something you've got to check depending on the specific switch you have in your setup. If you have, in my example, I have PoE switches that power a bunch of stuff, this can become highly relevant. So what you want to do, and once again, this will depend completely upon the router, the switch that you have, or your specific network configuration and setup. But if you're going more than likely from your initial gateway and router into a switch or something like this, then you need to check it. So in this specific one, if you come across into the specific VLAN settings under the port configuration, you need to make sure that the port types are set to unaware. So in this case, if a port is sent to a client port, which is the default for this switch, then what it will do is all traffic coming in and out of ports in each of the ports will be stripped of its tags, and then we'll have a new tag applied to it. Now what this means is, if in my instance at the wireless SSD, it is applying a tag of 30, and then your switch is stripping a tag off, and then you're trying to communicate down to the next level, it will not be able to correctly engage or interact with all of these things, and you'll have a bunch of issues. Because one way, the traffic will start with a red jersey, the jersey will be taken off, it'll go to the default, let's say is blue, goes to the router treats the traffic as if it's a blue jersey, so on the default number 1 VLAN, it'll send it back, and then when it goes to communicate back, your Wi-Fi SSD will just go, no, this traffic is not relevant to me, and you'll end up with block. The next bit I did was then, and the next problem I had was I identified that the ports on the inbound needed to strip that. So I set that up, and once again, the jerseys were then getting to the router all the way wearing a red jersey. On the way back, the moment they came out of port 10, they were once again then stripping that jersey off, and it once again was causing problems. So have a look at this. One of the ways that you can specifically identify these problems is track the traffic that's coming into your Edge router. Have a look at the specific packets that are coming. If you're getting packets and those packets are doing funny things, so in my instance, initially you saw it trying to communicate with the DNS for the specific VLAN that was set up, and then it was assigning an IP address going back. That then said to me the router was doing everything it needed to do. There was another problem going through. Now, what I've shown you then is the standard, what I would say is the standard no-frills setup when setting up VLANs. Depending on what you want to do as the next bit will determine what next steps you take in this. So in my instance at the moment, if we come across, I have a bunch of rules that are set up. Now, as I said, and I'm going to take you through the rules I have on my guest network and not set up anything for the new SSID that I've just set up, because at the moment I'm happy with that. Let's just go that I'm happy with that. But these rules inside here are how you determine what level of communication can occur between that VLAN and the other VLAN, or even that VLAN and other directly connected devices, or indeed the router. So in terms of my guest VLAN, I don't want my guests being able to talk to my router at all. Indeed, at my front door, I have a small panel, a NS Pro panel. One of the screens on that gives you a QR code that you scan to access the guest Wi-Fi. So when someone comes over, happy for them to access internet, but I don't want them having the ability to access anything else on my net. And this is why it's set up like this. So if we come and have a look, so the first one is the local. So I've set up a name called guest local for the firewall policies. And if we come and have a look at, the first bit is then set up is what interface and what direction, in this case local, so talking to the router specifically. And the default action for this is drop. So I don't want it to be able to talk to the router with the exception of a couple of specific cases. Those cases is like established or related traffic, so traffic that has already been allowed through for some specific reason, and the two specific examples, which are DNS and DHCP. By adding these, this allows your devices on that VLAN to get IP addresses and actually communicate with other stuff and gain access to the DNSs, but it prevents them from doing anything else with the router outside of those two specific things. And in fact, it will, as you can see, the default action from this is to drop all other traffic. So that's the first one. And the second one is traffic which is coming in from the VLAN. So from the VLAN, direction in, and this is defaulted to accept. So this allows traffic in particular to the internet and things like that. And as you'll see, it will accept established and related, it'll drop invalid, but then most importantly, it'll block other accesses. And you'll note here it says network group private nets. So let's have a look what that is and what that does. So when you come across to these rules, this one is a drop action for all protocols, and most importantly, it has this network group here set to private nets. What private nets is if you come across to the firewall groups, I have previously set up a group which includes all of the IP addresses in this line here, all of the IP addresses assigned to all of the VLANs that I have, or LANs and VLANs I have across my router. What this then meant, when we talk about the firewall rule, any traffic which comes from VLAN 20 in this instance, any traffic that comes in that goes to any IP address across my network directly is automatically dropped. So what that then means is my guests can't communicate with anything else on the networks whatsoever. And that is quite obviously, in my instance, and for most cases, probably the way you want it. Let's now I've given a description of that. Let's now look at how you can set up rules so that in this instance, your IoT network can't communicate with other different devices across the bits. So what we want to do firstly is, if we're talking about IoT things, we want the IoT devices to actually be able to talk to each other. And in particular, I have a Home Assistant server set up, and I want the smart devices in my home, I want them the ability to be able to talk to the Home Assistant server, which means it can't block every single IP address. So let's come across, and if we have a look at our firewall groups at the moment, we have a firewall group for VLAN 1, which is the default one, and that includes all of the devices on that first network. We have a group which is for the guest network, because we probably don't want and don't need our IoT things talking to our guest network and initiating communications. So these two are going to be the two relevant ones when we create our firewall policies for this. So the first one we're going to do is we're going to set up the local. So let's create a new rule set. Let's call it IoT local. And the default action is going to be the same as the guest local we've got, which is going to be drop. All right. So now we've got that IoT local which is being created. So now let's actually edit the bits. The first one I want to do is I want to select the interface, which is ETH.30, and the next bit I want to do is local. So we're talking to the router in this instance. I'm happy with that. I'm going to save that change first. The second bit is I want this to default to drop, because that is my default action, and rather than allowing everything and blocking specific things, I want to go the other way, which is block everything and then punch specific holes through. Now we need to add in the specific rule sets. So the first one I'm going to add in is for all protocols, and it is an accept, and it is established. So at established and related, allow established and related. So I'm happy enough with that. As you can see, established and related are good to go. So we save that one. The next one I want to drop invalid states. So we come across, we set that up, and we go drop invalid. So drop all protocols invalid state. Happy with that. The next two we want to do are to allow the DNS and DHCP. So let's go allow DNS, For allow DNS, for this to work, it needs to be both TCP and UDP. And when we go to destination, we're looking at a destination port of 53. And we save that once I've set the accept. So accept, TCP and UDP, none of these matter, and then we come across the destination port, and we want it to allow port 53 connections. And the last one we then add is allow DHCP, and we want to accept these connections. These connections will come across the UDP protocol, and the destination is going to be port 67. And now we save that. All right, so what that now has done is that has now meant that our connections along the VLAN 30 will by default be rejected if they're trying to talk to the router, with the exception of DNS requests or DHCP requests. So happy with that, and close out. The last one we want to have is the IoT, and this one's going to be in, and the default action for this is going to be accept. So we're happy with that, and we save that. As we did before, we want to set up the interface. So the interface is going to be port 7.30. The direction this time is in, so requests that come on the inbound direction. And then we come across to the rules for this. So the first rule we're going to add is the allow established and related. So accept all protocols, established, related, and we save that. The next one we want to do is the drop invalid state. So drop invalid, and we're good with that. And then the last one is, as I said, the IoT, we want to block access to VLAN 1 is the first bit. So this is now going to be action drop. And then we come across, we go to destination, we add network group, and we go VLAN 1 is the first bit. So we save that. That will now block all traffic, which is going to VLAN 1 from our VLAN 30. The next one we want to do is block guests. So once again, drop all protocols. Destination is going to be network group guest. All right, we save this and we jump out. And now what you'll find is we now have completely set up our VLAN for our IoT devices, which you've deployed across this server. All right, guys, so that's been a longer one than I anticipated for today. Happy enough with it at the moment, but what I'd like to say though is this can be a little bit complex, regardless of how much experience you've got in other things. If you haven't specifically set up VLANs before, there are a lot of catches and a lot of things that potentially will drive you absolutely bonkers. If you're having issues and you've got an Edge router, feel free to hit us up in the comments. I can have a look and see what additional assistance I can offer. Because the first time you set up one of these is painful. Once you've fallen into those pitfalls and you've got through it, it gets better, and it actually turns into less of a pain. And then after you've done a handful of these, it turns into second nature and you just fly through. And as you've seen today, it did not take very much time to set up a network, which is now, increase the security of the stuff that I'm doing. Anyway, guys, after all that, I hope this was helpful. I hope this was useful. I hope that by watching this video, you can avoid the pain that I experienced when I set up my first one of these. But as always, guys, have a great day and stay safe out there.